Although we're going to be going through De Morgan's law, on its own, that's not going to be enough when you come to simplifying expressions. You need to understand the main Boolean simplification laws. Now, to truly understand this, it's not a case of remembering it. You do need to go through and make sure you understand each rule before you move on. All right, because you're going to want to use these rules when simplifying Boolean algebra. So one example is a dot 1. So a and 1 is the same as saying a. Now, the reason for that is you can simplify a and 1 down to a. The reason you need to understand the reason truly, you need to view it as the logic circuit that it's representing. So if you think here, we've got a and 1. As we know with an AND gate, both of these outputs have to be true to produce an output here. Okay, so with this as our example, if a is 0, the output is 0. All right, because just because that's a 1, they both need to be a 1 for the output to be a 1. So if a is 0, the output is 0. If a is 1, the output is 1, which basically means the output is whatever a is. The 1 becomes irrelevant. Okay, so a and 1, you can simplify down to a. Now, there's quite a few laws like this, so we'll go through a few. So a and b is the same as saying b and a. So you can swap the letters around and mean the same things. Some of these are easy. A or b, same as saying b or a. A and 0 is always going to be 0, because remember with an AND gate, both sides have to be true for the output to be true. So if one side is 0, it's always going to be 0. So you can simplify it down to 0. An OR gate, if you've got a or 1, again, one or the other or both need to be a 1 for the output to be a 1. So there is never going to be a situation where this is going to be anything other than 1 if it's an OR gate with a on one side and 1 on the other. So you can simplify that down to just 1. A or 0, again, it's going to be whatever a is. Because if a is 1, the output will be 1. If a is 0, the output will be 0. So that can be simplified down to a. A and 1 is a. We did that on the previous example. A and a can be simplified down to a, because it's going to be whatever a is. A or a, same thing. Now, these are two examples of how you might see not a represented. I try and represent it with a line above. Because there's no way of doing a line on a keyboard, you might see it represented like that. Sometimes on a computer, don't worry about it. Just make sure you're aware that just means not a. So if you've got a and not a, the output's always going to be 0, because a can't be 1 because what not a is always going to be the inverse. So there's no way where both sides of that can be 1. So therefore the output's always 0. A or not a is always going to be 1. Because if one of those is a 0, the other one's a 1, because they're the inverse of each other. And you only need, with an OR gate, one side to be a 1 for the output to be a 1. So again, we can simplify that down to a 1. Not a is always equal to a. You'll understand that more when we do De Morgan's law, but if you're not something, you are something. All right, so if you're not a boy, you're a girl. If you're not a boy, then you are a boy. Okay. Then you've got A and B and C can be the same as saying you can move the letter that's outside the brackets. But to do this, you've got to make sure the operators are all the same. So outside the operator, you've got outside the brackets, sorry, you've got an and, inside you've got an and. So therefore it's the same as saying the different letters on the outside than the inside. You can do the same with or, as long as, again, the operators on the outside of the brackets are the same as on the inside. And then here, when the operators are different, you can't do that. But what you can do is you can say all the different combinations. So you can say with here, I could have A and B, or I could have A and C. Okay, so I'm multiplying out the brackets. All right, they're the simplification rules. They're the main ones. Making sure you're aware of them and you could do them. Basically comes down to just practice. You need to go through some of the questions that are linked on the key concepts map, the skills map, whatever you call it, because otherwise you won't have a true understanding of this. It all comes down to practice. But once you do practice, this becomes a more straightforward skill than it's probably deeming to you at the first time watching this video.